Okay, so yeah, this is the lecture 4, and actually what happened in the previous lecture, the camera was on full HD, so like after say 26 minutes and something, the video turned into another video. So that is why I plotted those 3 lectures saying lecture 3A, 3B, 3C. So now we are starting, that is actually lecture 3. So now we are starting lecture 4, and this class is going to be another like very interesting class for you guys, lecture 4, because for UPSC, for TIFR, for any exam, I am saying IIT exam, any exam you are writing, and mainly this batch is going for UPSC, mainly what? Solely. So for you guys, this chapter, and that chapter name is Real Sequences. Although we used to study these 2 chapters separately, but for me, as you are following this lecture series, you know I believe in concising the things. So for me, the chapter is Real Sequences and Series. So when I say series, and why I am consolidating, I am much focusing on consolidation, because at the end of the day the revision should be easy, otherwise with mathematics optional you will not able to perform. Getting my point? That is why all this exercise, because heavy booklets, heavy classes are already in the public domain. I am not going into that. So consolidation, this is the major portion for this real analysis for your UPSC optional. So what I will be doing in real sequences and series? So first is the sequence. Here I will be dealing, as we all know, teacher is in the habit of telling you the flow of the chapter. So flow of the chapter will be moving like this: definition, then questions based on definition, and questions based on limits. So what we study, Cauchy theorem on first Cauchy theorem, second Cauchy theorem, Cicero's theorem and all. So those limits, theorems, we will deal in the sub part of this first. Then we will be dealing about monotone convergence. Very important topic for us. In any of the year you will have questions from here. So monotone convergence के अंदर ही we will study about subsequences as well. Subsequences, then Weierstrass theorem, how we use that theorem to prove something, how some recurring formulas are easily proved convergent or divergent with the help of monotone convergence theorem. So this is the sequence. So real sequences के अंदर, this is the sub part first, this is the sub part second. After this we will summarize this chapter, and we will have ultimately hardly 5 to 6 points to remember. Okay, so for sequences we will do. After this I will just move on series part. So for series I will be starting as power series. So this lecture 4 maybe comprises of 3 subparts, 1 hour each, but everything I will be like dealing here only with this heading, real sequences and series. So when I talk about power series, I will be talking about radius of convergence or interval of convergence. Okay, power series, then expansion when it is possible. Series के अंदर another part we will have infinite series. इसके लिए we will check convergence and divergence. Convergence में भी another part will be absolute convergence. Got it? So this is the real sequences and series wala chapter. Here we will have different formulas, we will remember those, that is not a big deal. After this, all these sequence and series, we will move to functions, right? So functions, in case of functions, we will study functions, sequences, power series, just application part, and there we will be dealing uniform convergence and all, point wise convergence, series के अंदर series of functions. So this is the overall picture for real sequences and series, and after this we will slowly moving to the calculus wala, limit, continuity and differentiability wala. Okay, so this is the overall picture. Believe me dear, I know you are here to get the information, but I hardly believe in getting only the information. I am always focused on how you will frame that information. So doing this exercise, although I may think I should skip this part, but whenever I skip this part, you are going to learn nothing. So this is the most crucial part of this lecture series, directing the flow of the chapter, concising the concepts, comprehensive study. Okay. So as we all know that disciplined learning, that is the keyword for us lecture series. Okay, fine. So let's move on sequences. So tell me, what is the definition of sequence? Any of you? No. Limit ka existence. Okay. So merely it is not only the existence of limit. Please focus. First of all, we have to learn what is sequence. Okay. So what is sequence? So what is the definition? As we are in the habit now, learning definitions. So a sequence is a function. What? A sequence is a function from set of natural numbers to some set. Let's say I talk about real sequences. So what I'll say, xn be a real sequence. It means that xn is nothing but a function from set of natural numbers to set of real numbers. This domain will be always fixed. So by fixing this domain, what we actually mean here? We mean that we have x1, x2, x3, xn and so on. This x1 is nothing. I'm just saying what is the image of 1, what is the image of 2 and so on. So any sequence xn will be represented like this. These are called terms of sequence xn. Okay, means first term, second term, third term and so on. First, second समझ आ रहा है? So sequence, the term matters. Note it down please. For example, if we take two sequences like 1 minus 1, 1 minus 1 and another sequence yn as minus 1, 1, minus 1, 1 and so on. So these two sequences are equal? No, not equal. These two sequences are completely different sequences and answer lies here. What I told? Terms in a sequence are fixed. Why? Because when you say x2 means second term, it means that is representing image of 2. If I say here image of 2 is what? -1. Here image of 2 is +1. So if image is under some function is different, so those two functions cannot be same. Getting my point? Understanding why I told you the definition? Basic things are there, but I know because with my teaching experience over a decade, I've been seeing these things. These students don't know the basics of things. They know how to calculate the limit. They know better than me actually. But when I say what does it mean, whether these are two sequences are equal or same, they say, हाँ sir, हाँ. So this sort of thing. Okay? Getting? Definition is clear. Now I introduce one more term. एक तो हो गया terms of the sequence. The other term we use range of a sequence. Please focus on these terms, otherwise you will not enjoy this chapter. I'm pretty sure. So when I say range of a sequence, what does it mean actually? See, sequence is what? Repeat. Sequence is nothing but a function only. So if a sequence is nothing but a function only, if function is there, then domain is, so domain, so we have fixed set of natural number for a sequence, then range may differ. So if function is there, then obviously domain, codomain and range will be there. So sequence is nothing but a function only. So if sequence is a function, then definitely it will have domain and range. So domain of a sequence is always fixed set of natural number. Range may differ. So range of the sequence is what? That is the collection of all those elements which are images of 1, 2, 3 and so on. Means range is a subset of this part. So if I say what is the range of this sequence, this will come out as, please tell me, in the range part, in the images part, what we have? Either the +1 or the -1. So the range of the sequence xn is a set containing only two elements. Those are +1 or -1. If I talk about another sequence yn, so what is the range of yn? So sequence yn is nothing but a function only from set of natural number to some set. So that range, that image set contains two elements, -1 and 1 only. So what we can say here, these sequences are different but their range is same. Am I clear now? Everyone? Fine. So I hope definition, what does means terms of a sequence. So terms means fixed. If you change the place, sequence will be different. Two different sequences may have, please focus on the word, may have same range set. Getting? So this is the basic about the sequences. Okay. So now I am moving slowly. Sequence का boundedness or unboundedness. The other term we use, sequence is bounded and unbounded sequences. So what does it mean actually when I say a sequence is bounded? So a sequence xn is bounded if range set of sequence xn is bounded. And here please focus on bounded set, which was our first class where I told you what does mean of a bounded set. Means it will have its supremum as well as infimum. So when I say about boundedness of a sequence, it simply means the range set of that sequence is bounded. And if range set of some sequence is unbounded, then we say the sequence by n is unbounded. Am I clear? So in the previous example, when I had the sequence as 1 minus 1, 1 minus 1 and so on, other sequence I had minus 1, 1, minus 1, 1 and so on. Let's have the another sequence at Zn, and which is, let's say, given by 1, 2, 3, 4, 5 and so on. Let's have another sequence Wn, which is nothing, let's say 2, 4, 8 and so on. So here the range set is either 2 elements, 1 and minus 1. Here range set is minus 1, same. But here range set is clear. Check it out please. This is the set of natural numbers. So what does that mean? But set of natural number is unbounded. So what we will say? This sequence is unbounded, whereas this sequence is unbounded, whereas these two sequences are bounded. Am I clear to you all? So boundedness is clear. And please do remember these terms, otherwise you won't be able to solve. You are learning, button. So when I say boundedness and unboundedness, so that we will be using in the monotone convergence. Do remember it, okay? Now, I am coming on the point for which you people are waiting actually, and the point is what I mean by convergence of a sequence. Now, when I say convergence of a sequence, what does it actually mean? So in the BSc classes, you may have studied that if limit of xn exists finitely, you can say, then sequence xn converges to L. But does it the actual definition? No, simply no. This is the byproduct of some definition. So what does the definition of convergence? Here I will take some time, because once it is clear to you, you will feel it. Otherwise, for the whole life, you will be just do the Rattamar Jindavada. So I won't wish you will do the Rattamar Jindavad. You have to understand what is the convergence means. And please be concentrated just for 2 minutes only. So let's say we talk about real sequences. Our topic is real sequences. So let's say, Abhisindiya, a real sequence, please focus on the words. Xn is said to be convergent, or you can say converges to some real number L. Now the story starts. If for any given epsilon greater than 0, please focus here, any given epsilon, these words will matter for you. For any given epsilon greater than 0, there exists, when I say exist, it simply means a finite number. If there exists, although you don't be confused, so I will use there exists a finite natural or you can say positive integer, or maybe non-negative also, because from the sequence 1 only it may have 0 0 से converse कर जाए. So if there exists a finite number n such that, please focus on here, modulus of xn minus L is less than epsilon whenever n is, when I say xn, so here you can use the word m. Now this is the definition. So हमने किया क्या है, इसके अलावा everything we have marked up, but except what needed thing we always ignore. So what does this definition mean for you? Just I am showing you practically now. Let's see here. So when I say let's have a sequence, suppose that I had that sequence of 1 minus 1 1 minus 1 means I have taken that sequence xn. So if I have this sequence xn, let's represent it over the real line. So this is suppose that minus 1 and it is plus 1, such say it's a 0. So over the real line, what we are doing is, where is x1 dear? x1 will be the first term. Where is x2? Here only. Where is x3? Here only. Where is x4? Here, and so on. So what it is showing is x1, x3, x5, x7 are here. x2, x4, x6, x8 are here. Getting my point? Now I come on the definition. When I say a sequence is convergent, it simply means after some finite number of terms, the difference, what I told you in the previous class, this is modulus means difference between xn and L. So what does this definition mean is, after some finite number of terms, the difference between term of the sequence and L becomes very small. Am I clear to you all? Let's apply this definition here. So if I say let L equals 1 for this, I want to check if 1 is the limit of this sequence or not. So if 1 is the limit of this sequence, then difference between xn minus 1 must be less than epsilon for any epsilon. Let's say you take epsilon is equal to 1 by 2 or 1 by 3 or 1 by 4, doesn't matter. So if the difference between xn and 1 becomes less than epsilon for all n greater or equal to some finite positive integer or some finite number m. So if I say after 50,000 term, 50,000 1th term आएगा और 50,000 second term भी तो आएगा. So that will be fluctuating between 1 and minus 1. So if my term, suppose that x10, let's say x10, x10 minus 1, suppose that becomes 2, because x10 to minus 1 value देगा. So minus 1 minus 1, it is 2. If I say x11, x11 minus 1, it is 0, 1 minus 1. x11 minus 1, x10 minus 1, x12 minus 1, x13 minus 1. So क्या मैं ये कह सकता हूँ after some finite number of terms, difference between xn and 1 becoming less than epsilon? Not at all, because suppose that if 2 last term the difference becomes 0, then at the next term the difference will become 2, and the next term difference will again 0, the next term after difference will become 2. So means what I say, now come on the definition which I taught you, there for any epsilon greater than 0, there does not exist a finite positive integer or a finite number such that this condition holds. Am I clear to you all? So it's for you the definition part. If you have understood, then very well. Otherwise, rewind the video and see the video. So let's take some other examples. It's a very beautiful concept. Once it is clear, you will feel it actually. So when I take the sequence 1 minus 1 and all, the sequence does not converge. Now I am moving, let's say, if I take the sequence xn as some sequence 1 by n, where n belongs to natural number. So what I taught you guys, whenever you have been given some set in the representation form, you need to recognize that set. What? You have to recognize that set. So what is the recognition of this set is, when I put n equals 1, it will become 1. When I put n equals 2, it will become 1 by 2, then 1 by 3, and so on. So what does it mean actually? It means the term of the sequence x1, first term is 1, second term is 1 by 2, third term is 1 by 3, and so on. You getting my point? Any issue? Now, what I want to show you, what the definition of convergence means. See, if I keep on increasing this denominator, on getting for n tends to infinity, or you can say for very large value of n, 1 by n will tend to 0. Getting? So now I am interested in knowing, because I have the idea for L, okay, L equals to 0 may be the limit. From where I got this idea? I got this idea because if I do 1 upon 2 lakh, this value will be very closer to 0. If I do 1 upon 10 lakh, will be more closer to 0. So means I have opportunity that after 10 lakh terms, the difference between sequence ka term and 0 will be less than epsilon. And now to cross check this thing over the real line. So what we do, suppose that this is the 0, this is 1, so this will be 1 by 2, this will be 1 by 3, 1 by 4, and as the n will be increasing, the concentration of terms of the sequence will be increasing at the point x equals to 0. Is that clear? So now we wish to check 0 is the limit of sequence xn, or you can say xn converges to L or not. This we want to check now. So let's check. Practically, so I am giving you hint here over the real line. If you say ki yes, there exists, suppose that you take the value m ka value 50 lakhs. So what will happen after 50 lakh? What will x 50 lakh plus 1th term, this will be very closer to 0 or not? X 50 lakh plus 2th term will be closer to 0 or not? So it simply means xn minus 0, distance between xn minus and 0 is less than epsilon for any epsilon greater than 0. This is also a parenthetically small number whenever n is greater or equal to 50 lakh. Get it? So if I take x 50 lakh plus 1, x 50 lakh plus 2 and to infinity, this difference will be less than epsilon. So by this picture, what we feel actually is sequence xn converges to the value 0. Okay. Although I can prove this by Archimedean property also, but to make you understand the definition well, I am not going into that for the time being. Getting? Any issue? By using the Archimedean property, it can simply, no issue at all, 1 upon n minus 0, this will be less than epsilon. We will choose that epsilon or by the Archimedean property such that for any n, for there exists some natural number n greater than epsilon, means 1 upon n will be less than epsilon. So whenever I got 1 by n, this will be less than epsilon. What I used here? Archimedean property. This is also done in the class notes which you have been provided. So what does it mean actually? I was just focusing on to make you feel what does the convergence mean. Now you can enjoy. Suppose that I take a sequence, let's say xn is a sequence defined by 1 upon n square plus 1, where n belongs to natural numbers. So recognition of this sequence is 1 upon 1 का square plus 1. दूसरा term 1 upon 2 का square plus 1. Third term 1 upon 3 का square plus 1, and so on. So what will happen for n tends to infinity? 1 upon n square plus 1 will tend to 0. Means 0 will be the limit of this sequence. In the definition, L is the limit of that sequence action. Any issue in the visualization of sequences ka convergence ka mean? So if this does not happen, then that sequence means if sequence not convergent, then comes into the category of divergent, and divergence has two different categories. One is oscillating, okay, another is diverging to infinity or minus infinity. Am I clear to you all? Any doubt? Sequences का convergence you got or not? Now any sequence if you take and try to visualize that geometrically over the real line, and what I told you with that this help of this example, I am pretty much sure you will enjoy it. Abhi, let's move on. Okay. So one way is to get this convergence, meaning we have to understand the definition of convergence part. Now you can apply this definition over different examples. Examples and questions are given in the assignment. Now I am coming on the convergence ka other representation. Okay, definition is clear or not? नहीं है तो then do remind the video, because this is the part which I visualized in after my masters actually with the Walter and Sylvert. Now when I say by the definition कि for any convergent sequence, okay, now I am coming on other forms which you people usually used to use. For given epsilon greater than 0, there exists m belongs to n such that modulus of xn minus L is less than epsilon whenever n is greater or equal to m. Fine. So convergent sequence का definition, xn क्या बोलते हैं, xn converges to L if for any given epsilon greater than 0, revise and re-revise. Okay, such thing happens. This also can be represented by xn converging to L or limit n tending to infinity, xn is equal to L. So from here we start our next point, and that next point is, if you are able to find limit of some sequence, is finding limit for a given sequence. Finding limit for a given sequence. So here we take help of some, please note it down. You need to add in your notes theorems on limits. Suppose that you have been given some limit an, for example, if limit an is equal to, when I say limit, it means limit n tends to infinity, well understood, okay? L, then limit n tends to infinity, a1 plus a2 plus an by n will be L. Got it? First. Second, what you can say about limits ka logarithmic. Third, please note these points from the book Malik Arora. Although these are noted in your class notes which are floated in the Telegram group, there also I have given lot many examples there how to calculate limit. Am I clear to you, everyone? So this is simply whatever you were using in your BSc or BTech. There you were simply calculating limits. Okay. So what I am suggesting here, you have been given all theorems aligned. You need to remember these 4 to 5 theorems which I stated here. Okay. And by using these, if for a sequence, for example, if sequence is xn, 1 by n, n belongs to n. So limit n tends to infinity, 1 by n is 0. So what we can say, sequence xn converges to 0. By calculating such limits, you can tell whether the sequence is convergent or not. Fine. So this is task for you. You have to prepare these 4 to 5 theorems, and examples categorically are given in the class notes as well as in the book. So you are suggested to solve all those examples. What? You are suggested to solve all those examples. Although from my memory card I have remembered some example where you may feel some issue, so I will just give a glimpse over those. Suppose that you have a sequence xn. These are some examples where you may feel ki I am like bit facing difficulty. I am giving you where the nth term, okay, they have given nth term as 1 plus 2 plus 3 plus n upon n square, let's say, something like that. Or they have been given xn as n plus 1 up to plus n minus 1 divided by 2n plus 1, something like that. So in such kind of problems you may face difficulty. So for those I am suggesting you, my suggestion, recognize. If you are following this lecture series, you are able to understand what I mean by recognition. So in such examples, you just try to write what is x1, what is x2, what is x3 and so on. Means if in this sequence, if I say x1 will be what, this sequence mein x1 will be what. So if you are able to recognize these, then you will be able to figure out that what can happen for the convergence. Another suggestion is try to reach the last result. This is the very important and personal experience for my dear students. If you are thinking ki I will remember these limits and I will be able to solve the question, forget about it. You will never be able to solve the questions. remember the limits, try to apply the limits, figure out. Why I am able to figuring out such conditions? Because I have solved those examples multiple times and I know where you can have the problem. Is that clear? So what is suggested? Try to solve all examples in the Malik Arora book or the assignment. After that, consolidate your stuff and revise and re-revise. Am I clear to all? Shabko? In the next point here I will add for this part is limit, theorems on limit. एक तो these theorems मतलब formulas calculating limit, other is theorems on algebra of limit. So algebra means plus minus multiplication division. So limit xn plus minus limit by n, where xn is a sequence, yn is a sequence, limit xn plus minus limit by n. You are getting my point or not? Other is limit xn into yn, limit xn into limit yn. Because whenever you have some complicated terms, there you can use. So this is another most important exam point for you guys. And again I am saying I may take 2 hours lecture for this, but that is nothing more than a blunder, and I don't want to do that, because this is, if I am suggesting you, the algebra of limits is useful, and where it is useful means if you have some terms like suppose that, so you may consider this as xn and you may consider this as yn, just a mere example for you. And by calculating these two limits separately and using the algebra of limit, you can easily calculate limit of this sequence. Getting? So this is the picture for the introductory convergence of sequences. Am I clear to you? So this is bit homework for you. Please solve those examples. Let me know if you are not able to solve. I will solve those in the assignment wala class. Okay? But please try. So now I would like to move on. Monotone convergence. That is another beautiful concept for you guys. So as we all know, I am always concerned about the definition, then using that definition to get the desired results. So monotone comes with monotonically increasing, monotonically decreasing. For example, if I talk about the sequence 1, 2, 3, 4, 5 and so on, so this sequence is monotonically increasing. If I talk about the sequence 1, 1 by 2, 1 by 3, 1 by 4, so this sequence is monotonically decreasing. If I talk about the sequence 1 minus 1, 1 minus 1, this sequence is monotonically increasing. This sequence is monotonically decreasing. This sequence is not monotonic, because you can never judge that where it is going to be increasing and decreasing. Getting? So this sequence is not monotonic. Another interesting concept you can think of from here only, when we will discuss the subsequences, definitely will be coming on that. Although this sequence is not monotonic, but we can create some subsequences, let's say Wn and W dash n from this sequence, sequence converges of first term, third term, fifth term and so on. Second sequence -1, -1. This sequence is monotonically increasing, this sequence is monotonically decreasing. Monotonically increasing means not decreasing. This is another term for use. Decreasing means not increasing. So if terms are being constant, still it comes under the category of monotonicity, and you call it monotonically increasing or decreasing. Getting my point or not? So this is a constant sequence, you call it as. So constant sequence can come under any of the category. Another word that is used is strictly increasing and strictly decreasing. Okay. So constant sequences do not come under the category of strictness. I hope this is clear now. Getting? Monotonicity is clear. In definition, if you want to say कि xn plus 1 is greater or equal to xn for all n, ये किसके लिए हो जाएगा? Increasing के लिए. इसका रिवर्स कर देंगे तो decreasing के लिए. Getting? Mathematically is that. So why we are studying this concept? That is the point of concern here. So let's go into that. And from here you will definitely have question in your exam. Monotone convergence. When I talk about monotonicity, I told you the definition. There is a theorem, monotone convergence theorem. So what happens is, no one is going to ask you the proof of that monotone convergence. Still I have done that in the class notes in very simple manner. So you can go through that. For here, what I say is, I should know what is monotone convergence theorem. Okay? So you may have two cases, right? A sequence may be monotonically increasing, a sequence may be monotonically decreasing. Okay? So what it says, if some sequence xn is monotonically increasing and its upper bound, please focus here, is capital M. What it says, कि if some sequence is monotonically increasing but its upper bound is capital M, then this sequence xn converges to M. Please notice this point. Other part is, if some sequence is monotonically decreasing and its greatest lower bound, infimum or lower bound you can say, is small m, then sequence yn converges to small m. So why it is of so much importance? Why I am again and again saying monotone convergence is very important for you? Because in the previous part we have seen that to calculate the limit, to check the convergence, what we need? Calculate limit. Okay. Calculating the limit may be a tedious process. Suppose that you forget the formula of those theorems, of those limit theorems. Then in that case you have another instrument which you can use to check the convergence of a sequence. So to check the convergence of a sequence, monotone convergence, how it will have? Step 1, please be focused here. Check the monotonicity of given sequence. Monotonicity, how we will check? Ki whether x2 greater or equal to x1, x3 greater or equal to x3 and so on. In general, xn greater or equal to xn or not? By my experience, I am telling you here, mathematical induction method helps you. Okay? So why I have written here? Because I know you people will face how to check this monotonicity is a tedious process. No. If your mind is stable, okay, if I want to check the monotonicity, I will be needing mathematical induction method. Means if I am able to show it is true for n equals to 1, 2, 3 and that it's true for k, then I need to show it is also true for k plus 1. Getting? So that is mathematical induction method. Am I clear? With one example, I'll do that. So when I want to check the convergence, I may follow this calculating limit part or I may follow the monotone convergence part. Am I clear to you? So for monotone convergence theorem, to use monotone convergence theorem, I will have to follow the step 1 and check the monotonicity. For checking the monotonicity, I will take help of mathematical induction. Step 2. If that sequence comes out as monotonically increasing, I will check the upper bound of that sequence, means the highest element or you can say range set ka upper bound. What I will check? Range set ka upper bound. In case of monotonically decreasing, I will just check us range set ka lower bound. So step 2 is getting bounds, be it upper bound or lower bound. ये किस केस में? Monotonically increasing and it in case of monotonically decreasing. You getting my point or not? So suppose that this M here, the point to be noticed कि whether sequence will converge to capital M or not. So getting the upper bound here is not the complete task. The task is कि this is possible or not. Getting? Okay. And you know why I am focusing on here actually? Because I know many of you have studied these stuff. Whoever studying first time, for them I should say कि you should go like this. First understand the definition, what is the monotone convergence means, whether यही limit होगा कि some other limit will be there, bounds and limits will be same or not. That is the question for us. You getting my point? So if a sequence xn, suppose that is less or equal to capital M, then what we can say about the limit of the sequence? For that, whatever the formula, let's say I have been given an plus, for example, if I have been given an plus defined as an plus 1 equals to an minus 1 upon 2. Okay, n belongs to n, 1, 2, 3 and so on. So if some sequence an is given like this and I want to check the convergence of this sequence, be on the board please. Step 1, check the monotonicity. So suppose that it is given that a1 is positive or greater or equal to 0. So what I can say about a2, what I can say about a3, suppose that this coming out monotonic increasing. I am not saying it is coming, you need to check. Getting? If it comes out as monotonically increasing, then by and bounded, then by monotone convergence theorem we can say that it is convergent. So now the very first point which you studied during your college days, that I left there. Now I am discussing that if sequence xn converges to L, then L is unique. Means a sequence cannot converge to two different limits. So when we use this monotone convergence theorem, if I am able to check that this sequence is monotonic and bounded, then by monotone convergence theorem we say that this sequence will be convergent. These bounds may or may not be limit of the sequence. For getting the limit of the sequence, that is the third step here. Step 3 is getting the limit of the sequence. So if I say that sequence AN converges to L, so sequence AN plus 1, after just one term, this will also converge to L. Because after leaving some finite number of terms, the sequence ka convergence does not alter or does not change. Getting? So I will use this thing here. So limit, taking the limit on both sides. So if this comes out to be monotonic, I will have something like this. Something like that. If this comes out to be convergence, just for example only I said that. So you may take one here, one here, one here. So it comes out to be plus 1. Something like that you can thought of. My suggestion is to create some sequences, although you may take help of that Malik Arora book or the class notes or assignments examples. You can have these questions out. My suggestion for you, don't go for directly answers. First try to use this rigorous process. Once you realize this process, you will feel very beautiful. Okay? So this is monotone convergence theorem. Although I planned that I will do in the next lecture, but I have done here because I wanted to do questions in the next lecture. So questions based on this or previous discussion, that will be a separate lecture in the next discussion. There I will be also discussing about subsequences and Bolzano-Weierstrass theorem. Okay, so you people are suggested to revise this stuff, and we will meet in the next lecture. We will do all these examples on monotone convergence. Till then, tada, bye bye. Stay tuned. Keep learning.